Hi guys, and welcome to this my video on the intercept slope form of the equation of a straight line, or something along those lines. Yes, my name's Darren, Maths Guru. Thank you very much for joining me. If this is the first time here, I'm going to kick in with the work in just a moment, but if you can subscribe to my YouTube channel, that would be great. And as you can see above me, there's mathsguru.com with all of these videos with time codes and downloadable notes and exam questions and so much more. Head over there if you can. All right, what are we going to do now? Well, this is building on the previous lessons we've been dealing with, the part of this general maths course. And if you don't know what general maths is, don't worry about it, it's fine. All of this stuff is universal. And so you should be able to hopefully pick up what it is I is doing. Thank you very much. But we're going to understand how to determine the intercept and slope of a straight line graph from its equation. And there are some tricks, Barry's at it again, and use the gradient intercept form to sketch a graph. Oh, sketch. Well, previously we plotted graphs. If you remember, in a previous video, we had an equation and we plotted them. Now we're going to sketch using some information. And that does not mean we're going to become some sort of Picasso. We're going to do this mathematically. Now, in the previous video, we looked at how we can sketch graphs. As I said here, we're going to look at only graphing straight line graphs. That's it for this course. Later on, if you do other parts of the course, you can do all sorts of funky stuff. Now, we have said already that a straight line graph has the form of y equals mx plus c. Yes? Now, we know that the m stands for the gradient. That was a measure of the slope of the line. And we found out we could have positive, negative, 0, and infinite slopes. All right, so again, if you don't know what that's talking about, head over to Maths Guru, have a look at the video. It's actually pretty good. It's a precursor to this one. Yeah. What else do we know? We know that c basically was the intercept on the y-axis. And what does that mean? There's your y-axis. Where the line crosses, that's what we call the intercept. Yeah. Now we've got a way of finding the gradient, blah, 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 blah. We know the intercept, it cuts on the vertical axis. So let's have a go at sketching these things. But how is Barry going to trick us? Oh, yes. Now, basically, if you're going to do further maths here in Australia or any further course that deals with statistics, they're going to try and throw you. And basically, rather than writing the equation, as I've said here, in the form of y equals mx plus c, they're going to try and trick you, and they may write it in the form of y equals a plus bx. Now, there are reasons for this, and if you want to know why, head over to the Further Maths course, find out the videos, and I'll explain a little bit more about university. But actually, as far as we're concerned, the equation of a straight line is y equals mx plus c, or it can be written like this. And you can say, what does that even mean? Okay, well, for example, if I wrote y equals 3x plus 2, we like that, thank you very much, because that's in the form of y is equal to mx plus c. Now, basically, what we're saying is the x term is first. What do we notice here? The x term is first. And this constant, this number term is at the end. But we know with mathematics, we can actually swap the terms. And so long as we keep the signs the same, then we should be okay. So actually, I could write this as y is equal to 2 plus 3x. Now, funnily enough, that's now in the form of y equals a plus bx. And you're going to say, well, hold on a moment. Isn't that just the same as y equals c plus mx? And I'm going to say to you, yes, actually it is. And Barry, really, when I find him, I'm going to smack him in the head repeatedly with a feather, because we don't condone violence on mathsguru.com, because that would be silly. So basically, they're going to swap this around and they're going to try and confuse you. But my advice is, if they give you an equation in the form of y equals 6 minus 2x, for example, swap it around. Now again, in this situation, that minus sign belongs to the 2x, so that becomes minus 2x plus 6. And looking at it that way, I now know what the intercept is, I know what the gradient is, life is good. And I also know whether the line's going to slope up or slope down. Down? Okay, down. Right, so as I say, we're not going to get tricked here. These notes are all downloadable from mathsguru.com, remember? Yes? Why do we call it y and x? If you remember, it's simply because when we draw a set of axes, for some strange reason, we always call it x and y. That's really what the letters are for. If I had a set of axes that had, p and q on it, then my equation would start that q is equal to something p plus or minus something. Yeah? So again, if we go back to a previous video, this is a relationship. In this situation, to get the value of y, we take the value of x and do some funky maths to it, i.e. multiply and add, or multiply and take away, and then we get our value of y. It's a relationship. All right, here we go. So let's do some examples. There are 4 examples here where hopefully you can see what I now mean. So we got the first one that says y equals minus 6 plus 9x. And the question says, write down the y-intercept and the slope of each of these straight line graphs. Now, in this situation, I want to make sure that it's y equals mx plus c. And you might turn and say, I can do it in my head now. Awesome. Some people go, oh, the thing that's stuck to the x But again, things become a little bit challenging later on with that type of thing. Right, but anyway, so in this situation, I'm going to rearrange it. Y is equal to 9x minus 6. And remember that minus belongs to the 6. It must stay with the 6. And now I'm going to compare it to y equals mx plus c. Well, m stands for the gradient. So that first one, the gradient of that is equal to 9. Or we could say 9 on 1, but in many cases we say 9. And my intercept value then is equal to minus 6. Now, the y-intercept should normally be given as a coordinate. Yes, because that's what the y-intercept is. It's a coordinate. So actually, in this situation, I'm going to write it as 0 minus 6, because if you remember, the y-intercept here, my line would do something like this, and it would cross through there at negative 6. And we know that that would be 0 across and 6 down. Ooh, we've done that one. Ka-ching. Let's do the next one. Y is equal to 10 minus 5x. Doesn't this look exactly the same as the previous one? Yes, it does, but the minus signs are things that trick people. So we get y is equal to minus 5x plus 10. Yes, that minus sign belongs to the 5, and the 10 has a plus in front of it. You can say, but there's no plus. And I'm going to say, aha, yes, there is. Whenever there is a number without a plus in front of it, it's a plus. So again, what do we find here? So now my gradient is equal to negative 5. All right, so that means it's going to slope down now, which should be negative 5 on 1, really, because we do rise over 1. Anyway, and my intercept here is 10. And if we think about that, that would be now 0, 10. See where we go? Right. Are you ready for the next one? Y is equal to minus 2x. Hold on a moment. There's no number at the end. Actually, there is. It is a humongous trick, because actually there is a plus 0 there. Now, obviously, we don't in maths write the plus 0, but weirdly, it becomes important when we do straight line graphs. Why? Well, because now if we compare this, we now know that m is equal to minus 2, pa-ching, and my intercept is equal to 0, which is otherwise known as the origin. Yes. Oh, I feel like I'm doing Sesame Street. Oh, my name is a count and I love to count. Yeah, no. All right. And the last one here, and this is the one that tends to trick people. So you remember a moment ago, people go, oh, it's just the letter or the number in front of the x. It is, but not here. Now, funnily enough, most people go, well, in which case I'm going to have the gradient as minus 4, and then you've just got the question wrong. Why? Because you have been a trickhead, yes. Now, obviously, we want the y on its own, but in this situation, the y isn't on its own. It has that minus 4x there. So I add on 4x to both sides, gives me y is equal to 4x plus 5, and suddenly we notice my gradient isn't negative 4 at all. It is positive 4. So in that situation, m would equal 4 and c would equal 5, which would mean that we would have the coordinate position 0, 5. Now, these are just some of the tricks they can involve. But my advice is always try and get it into the format of y equals mx plus c. Now, again, although these notes are downloadable from Maths Guru, you should print them out before I teach, and you can write all over them with your own stuff as well. All right, what about this one here? Well, maths can do things forwards as well as backwards, and so what we're going to now do is do this backwards. We know that the equation of a straight line is given by y equals mx plus c. So what about now if they give me the gradient and the intercept? Can I create my equation of a straight line? Well, I should, Coco, because in fact I think this is easier than the previous stuff. Here we go. So let's do this one here first. The y-intercept is 9, so we're going to write y is equal to, and the slope is 6. Now remember, the slope stands for the letter m, so that becomes 6x plus 9. Why is it plus 9? Because my intercept is positive, so I write the plus 9 there. My slope is positive, so I just write the 6, and ka-ching, really, that's all there is to it. What about this one here? Okay, and so the second one, we're going to have y-intercept is 2, and the slope is negative 5. So remember, we have minus 5x plus 2, yes? Now, when I did this one a moment ago, and you won't know that because I've deleted it, I actually got them completely the wrong way around, and that was so annoying, yes? And you have to be very careful with these questions because they're so easy to trick you. So the last one here is the y-intercept is negative 3, my slope is 2, and there we go, 2x minus 3. Ka-ching, this stuff is awesome. Now, what is the difference between sketching a graph and plotting a graph? We've already found out if we have an equation, we can do a table of results, we can do that, we can plot the graph, yada, 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 too boring. Don't want to do that in any way, shape or form. What if we can actually do this in a simpler way? Well, believe it or not, I think of the equation of a straight line as a funky thing of like here. So y equals 2x minus 1. This here is effectively one of the points on my line. I actually think of it as the starting point. I'll show you why in a moment, because that's the one I'm going to plot first. Remember, this one here is my value of c. It's my y-axis intercept, and it's at -1. So the first thing I'm going to do is do a cross at -1. Ka-ching, thank you very much. I would do a happy dance, but that's not necessarily going to help. Now, the one that tricks people is this one here. That's my gradient. So if you remember, my gradient, which is m, is written as 2, but realistically speaking, it must be written as a fraction. And any whole number, like the number 2, can be written as a fraction. Why is this important to me? Because we know that that is equal to the rise divided by the run, and that means the up or down divided by the run. Now, I always have the run as positive. I always have the run as going that way. So what this actually means is, for every 2 up, I go 1 across. Now, how is that helpful to me? Well, do you notice my grid? It's got little squares. Just counting. This is literally just counting. So I'm going to go 1 across to here and 2 squares up, and I'm going to do a kiss. Can I draw my straight line now? Theoretically, I could, but generally it's actually easier to draw a straight line when we have 3 or more points. And I generally do 3. So I'm going to go 1 across, 2 up, 1 across, 2 up, and ladies and gentlemen, ka-ching, there we go. Now, drawing this really badly because I'm trying to do it with electricity. If you draw it to there, unfortunately, you are wrong. Because what we now do is, obviously, once we've got that ruler, is I can draw the line, and that looks nothing like a straight line. We should realistically put arrows on the end there to say to our examiner, we know that that line is going to continue to infinity and beyond. And ladies and gentlemen, there we go. We've plotted. Now again, at any point, if you're like, how do I do this? And I'm like, what do you mean, how do you do this? Stop it. If I'm making no sense, rewind, start again, have a look, leave me a comment on YouTube, that'd be useful. Right, okay, there's another way to sketch a graph. Rather than do that, it's possible to find 2 points and connect the 2 points. I really don't like this way at all. So what they say is just choose 2 points. The first one we do is when x equals 0. Normally they choose x equals 0 as a point. And what we would know there is we know that that's 2 times x plus 1. We know that x is 0, so that's 2 times 0 plus 1. 2 times 0 is 0, and so we have 0, comma, sorry, is that plus 1? That should be -1. Read the question, Darren. That should be -1, and there we go. When I'm turning around saying, well, that was a bit pointless because we already knew that that was the intercept. We did. What about if we choose now x is equal to, just choose the number 2. Now you're going to say, why did I choose 2? No idea. Choose a number that's relatively easy to do. So again, we have y is equal to 2 times x minus 1. We know that x in this situation is 2. We do the multiplication first, which is 2 times 2. Then we take away 1, which gives me 3. And remember, that's a coordinate. When x is 2, y is equal to 3. So it's 2 across and 3 up. And ladies and gentlemen, I'm going to do this horrendously badly. But there we go. Roughly speaking, there is, what am I doing? That's supposed to be an arrow. Let's not put that x there. And an arrow there. And there's my straight line. Okay? Don't know why we would do that. Here's another example. In fact, it's the last example of here, and you'll notice I'm trying to trick you. Let's ramp up the complexity. Is this equation written in y equals mx plus c form? No, it isn't. So the first thing I'm going to do is write y is equal to 8 plus 2x and rearrange it to give me y is equal to 2x plus 8. How does that help me? That tells me my intercept is 0, 8. That's a coordinate. And this here tells me that it has a gradient of 2 on 1. So that means 2 up for every 1 across. All right, but there's no axes. How do I do this? Well, ladies and gentlemen, sometimes you're going to have to draw your own axes. How do we do this? Well, the first thing is, I know that my graph has to start at 8, and it's going to have a positive gradient. So it's actually going to slope up. Now, there are lots and lots of ways of doing this. So I'm actually going to start my graph at 0, and then we go 2, 4, 6, 8. And you're going to say, well, how high do I go? And I'm going to say as high as you need to. I wouldn't go much higher than that, realistically speaking. So there's my y. And then what am I going to go? I'm going to go 1, 2, 3, 4, 5, 6, 7. 1, 2. Now, I may not use all of this, but if you actually draw these in pencil, you can actually rub bits out or add bits if you need to. So let's see what we're going to do. Do we know my start point, or do I know one of my points on there is 0, 8? So changing color, let's do that here. There is 0, 8. Now what do? Well, we use my gradient. Remember, 2 on 1 is 2 up for every 1 to the right. So 1 right, and 2 up puts me there. 1 right and 2 up puts me... Oh, hold on a moment. Did I do 2 up? I got tricked again. My scale nearly tricked me. I'm redrawing the part of the graph that's just got deleted. And because my scale goes up in 2s, I'm actually going to go 1 square up and 2 square across. 1 square up and 2 up. 1 square across and 2 up. Now, lots of people will be screaming at me now going, well, why didn't you use a better scale? The point of it is you can use whatever scale you need to make it fit. And what do you notice there? Does that even look straight? No, not at all. So the problem we're going to have now is trying to draw a straight line through that. But ladies and gentlemen, there is my straight line. Now, ideally, it should continue back that way because remember, this graph goes to infinity and beyond. And I always think of my axes as having an invisible frame around them. Yeah, so this dotted line I'm drawing at the moment, and you would never draw this dotted line, by the way, because it would be a waste of your time, is actually where I would draw my graph going to. So it goes to those bounds there. And again, you examiner knows that you're clever enough to know that that graph goes to infinity and beyond. Now again, if you didn't understand that, pause it, take it back, send me an email, say, oh, you know what, Maffs Guru, you stuffed that up at the end, didn't you? And I'll be like, I'm so sorry. But anyway, life goes on. I'm done. There is a couple more minutes left to this video. Hopefully you'll watch them. If not, I'm going to say thank you very much for watching, and I look forward to seeing you in another video. Take care, guys. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is maffsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.